This is Floyd, and this is my glider project. So my glider's name is Betty, and it is from a Taylor Swift lyric that says broken wings, because I actually broke my wing upon testing. So the general idea of this project is to consider requirements, analyze different designs, build based on those designs, test, and then iterate, and basically go through that cycle while being creative and trying to get the best flight out of a glider. So the requirements are shown here. Must be built from the materials given, hand thrown, fit into a 16 by 16 inch box, remain intact for the flight, and must fly a minimum of 20 feet. Some measures of success are use only given materials. I felt comfortable doing that because I use balsa a lot in Design Build Fly Club, having precision in measurements, performing multiple iterations of designs, and recording data. So these are some wing shapes that I considered for different alternatives for my glider: elliptical, straight, and tapered. Elliptical is kind of the best that I found from my research in terms of stability, but a con is that it can be hard to produce. Straight is good because it's simplistic, but a con of that is that it's just not really good for stability. Tapered is really good in stability, but requires a little bit more detail in the production of it. As for tail configuration, I considered conventional, T-tail, and V-tail. Conventional is good because it's just kind of a simplistic, everyone knows what it is, kind of easy to visualize and build, but a con is that the horizontal stabilizer is right in line with the air that comes out of the wingspan in flight, so probably not the best. T-tail is good because it's kind of simplistic and easy to make, but a con is that it is prone to stalling. V-tail is good for several reasons. Only has two aspects of it, so it's easy to make, simple. It actually reduces the overall weight of the glider, which is really good for lift, and it also aids in stability. A con is that the angles of the two aspects might be hard to produce. And then as for the adhesives, I considered hot glue, wood glue, and super glue. Hot glue would be good because I already have it in my apartment, but it's kind of clunky and bulky to use with the delicate balsa. The wood glue is good because it is made for wood, but still a bit heavy for the balsa, so maybe not. That's a proposed con of that. Super glue is good because it is very thin and strong, which is good for the balsa. But a con is that I didn't have it in my apartment, so I would have to go to the AMS to use that. So some alternatives with the highest probability of success. The winners of those categories are basically the tapered wing, V-tail, and super glue. So as for the sizing, I wanted the lightest design possible while maintaining proper CG, largest wingspan while keeping it within the sizing guidelines of 16 by 16. And there's a photo of it in the square. So for the initial concept, I really wanted to have the simplest design that weighed the least. But after researching more, I figured out that doing things like perhaps making, instead of a straight wing shape, a tapered, although the straight is simplistic and easy to make, the tapered had a better stability. So doing things like that created more stability, which is more important for this project. As for testing, I played around with the location of the Play-Doh, added more Play-Doh. I found out that the wing was slightly on the longer side on one of the sides, so that was good that I was able to catch that and create another iteration. And it did actually go 20 feet within my first round of testing. So design iteration. So I decided that I wanted a more detailed wing. So after I did that straight wing, I decided I wanted the tapered instead. And I did that by actually using AutoCAD and the laser cutter in the AMS, and by sanding as well. So a second aspect for improvement would be the tail. I wanted to just really line up the angles and make sure that each side of the V-tail was the same. in order to create the maximum stability I could have. So here's a photo of my final design. So these are my CL, CD, and CG calculations. So my CL ended up being 0.349. Oh, sorry, 2.19, excuse me. My CD ended up being 0.62, and my center of gravity is right at the quarter chord of the glider wing. So as for my design iterations and how they compare to the final performance, making the wing shape more detailed aided in stability. Noticing the longer length on one side of the wing was really good, and it caused me to do another iteration. And considering the V-tail angle on both sides with more precision led to a lot more stability as well. So here's my best test flight, a quick video of that. Right, and then I figured out that yes, my design did actually meet all of the requirements. And here's my glider tournament video. And in conclusion, I feel that this project really helped me learn how the design process aids in bringing ideas to life. Instead of just kind of going with one idea and being done with it, creating multiple iterations can really help to have more fullness in your ideas. For future improvements, I want to sand the fuselage more. And as for the references, I looked at these websites and some mentors in the AMS. Thanks for watching.